Mhm. Yan. So, okay, no? So, once again, guys, welcome back, no, sa ating lecture sa, okay, Transmission Media and Antenna Systems. Lecture 1, Transmission Lines Part 2, no? So, this is a continuation of our lesson last week, no, about transmission lines. Okay, so, bale, game. Let's do this. So, quote for the day muna guys, no? So before we start our session, no? So, yung quote natin for today is all of your dreams will come true, no? If you have the courage to pursue them. So, this is from Walt Disney, okay? So, I know guys na siguro kilala niyo naman 'yan, 'di ba? Si Walt Disney and the characters no of the Disney, right? Sabi daw dito no na all of your dreams daw, lahat daw ng mga pangarap nyo ay magkakatotoo no if you have the courage to pursue it. Alright? So, all of us guys, no, may iba't ibang mga dreams sa buhay. Meron tayong mga pangarap. But I think one of them is to become an engineer someday. Tama ba? Yes, di ba? So, ang dream, of course, kasama sa mga pangarap nyo is to graduate, di ba? College, take the board exam, pass the board exam, and finally affix the word engineer in front of your names. Yes? Yes. No, so magkakatotoo lang daw yun guys, no, if you have the courage, no, to pursue it. Because oftentimes, no, what hinders us from achieving our dreams is the fear, right? Natatakot tayo. We fear fear of failure, right? 'Di ba? But also remember guys, no, may mga kasabihan na it's only considered failure no if you will not try, no? Oh, so wag kayong matakot guys no na mag-fail. For example, bawa nag-fail kayo sa Transma, oh, 'di ba? Oh, pwede niyo naman siyang i-take next time. Okay? So wag kayong matatakot guys. Okay? Oh, no, so you need to have the courage, no, to face, no, whatever topic we have right now. All right, no. So joke lang yun, guys, no. Pero pwede rin, 'di ba? Okay. So, dami. Lesson objectives, no? So, what will be the topic, no, for our lesson for today? So, after completing this lecture, okay, you should be able to, number one, okay, define what is a transverse electromagnetic wave and discuss its relationship in with the transmission line. Okay, next is derive equations in relation with the velocity of propagation. Okay, next is to define the velocity factor and discuss the parameter that influences it. Okay, then we're gonna solve some problems involving velocity of propagation. Next part ng ating lecture is we're going to understand no the concept of reflection in transmission lines, and then we're going to define and discuss no reflection coefficient and standing waves, and then we're gonna solve problems involving reflections. Okay. Yan. So next guys is I don't know we're going to calculate. Okay, or yeah, calculate no the impedance of a certain section of a transmission line. Okay, and then understand the various transmission line instruments and devices, and finally solve problems on transmission line system analysis. So, hindi natin matatapos to lahat today. So, we'll be continuing yung maiiwan next week, guys, to. But we will try to cover as much as we can. Okay? All right. So, game. Let's do this, guys. All right, no? So, let's talk about no transverse electromagnetic wave. Ano ba yung TEM wave na yan? Okay, so transverse electromagnetic wave basically is a form of radiant energy, essentially an oscillatory disturbance in free space that is composed of two components, the electric field and the magnetic field. Hence the name electromagnetic. Okay? So, ngayon, ano naman ibig sabihin ng transverse? So, it refers to the orientation, no? So, yung electric field at magnetic field nyo, as you can see in the figure, yung violet and yung orange, they are perpendicular with each other and to the direction of propagation as well. So, nakita nyo guys? So, paano ba, paano ba na-visualize yan in real life? So, for example, no? Teka, let me turn off my virtual background so you can see my... Okay? So, tinurn off ko na ang ating virtual background. Okay. So, itong thumb natin, guys, no? This is our, electric field. Okay? Electric field yan. Tapos itong ano natin, itong middle finger natin, ito yung magnetic field natin. And then yung index finger, guys, okay? So, kunyari nasa bahay kayo nanonood, gayahin nyo ako ha. Ang index finger natin, that is the, ano naman, direction of propagation. As you can see, no, yan, ganyan yung itsura niyan. So, this is the electric field, this is the magnetic field, and the direction of propagation. Yeah, di ba? Gangster symbol, no? Ng transverse electromagnetic wave. Okay? So it means that kung pataas ang electric field mo, pakaliwa yung pakanan ba? Pakaliwa yung magnetic field mo. So towards the screen yung direction ng ating propagation. All right? So I hope na nagagets nyo guys, no? No? So ganun pala yan, no? So ibig sabihin yung ano natin, yung thumb natin, no? Yun yung ano natin. Yun yung electric field, yung pang-PACU, yun yung magnetic field. Tapos yung index finger, yun yung guys, yun yung direction of propagation, no? So pag galit ka, no, instead of you say PACU ka, no, sabihin mo ka, magnetic field ka, di ba? Medyo scientific, no, ang pagmumura. Okay? So, joke lang yun guys, ako yung gagawin pero pwede rin. Alright? So, ano kinalaman nito by the way, sir, sa lesson natin? Kasi yung signal na nagta-travel sa transmission line, okay, hindi lang siya basta current, no? Yung properties niya is similar or actually that same sa property ng transverse electromagnetic wave. In fact, guys, no, we can consider that the signal traveling in a transmission line is actually a transverse electromagnetic wave. Okay? So, hindi na siya basta simple current lang. So, TEM wave na siya. Okay, na nagta-travel sa iyong transmission line. Okay? So, kaya natin pinag-aaralan si TEM wave. Now guys, let's talk about how fast does the TEM wave travel. So ano ba mga example ng TEM wave? No? So the most popular example of a transverse electromagnetic wave is light. Okay? So light is an example of a transverse electromagnetic wave. So ibig sabihin, by the way, are you familiar with the speed of light? So can anyone give the value for the speed of light? Oh, ano yung value na ginagamit natin for the speed of light? We have what? Uh, okay, 3 times 10 to the 8. Okay, question mark. Okay. So, anong unit niyan, no? Yan, very good. 3 times 10 to the 8 meters per second. But that is only, do you know guys that that is only the approximate value? So the exact value of the speed of light is 299,792,458 meters per second. Okay? So, approximate lang yan ha, yung 3 times 10 to the 8. The exact value is 299,792,458 meters per second. But of course, when doing calculations, so yung 3 times 10 to the 8 na lang gamitin natin. Okay? Ano palang symbol or notation ang ginagamit natin for the speed of light? Anong letter sa speed of light? Okay, C. Lowercase letter C ha. Lowercase letter C. Okay, lowercase letter C. Hindi uppercase ha. Lowercase guys. All right. Lowercase letter C. Okay, so bakit letter C? Di ba? Di ba? Malayo naman, speed of light. But hindi S. But hindi, S-O-L. Ganon, no? So bakit C? No? So it came from a Latin word, no? So celeritas, no? Oh, celeritas. Kasi they thought of light to be a fluid, no? Parang fluid floating around or flowing around the earth. Okay? So yung C na yun ang galing sa celeritas. Okay? So trivia lang guys. Okay. So now, ibig sabihin, yung speed pala ng transverse electromagnetic wave is 3 times 10 to the 8 meters per second. 'Di ba? Because yung light is considered to be a transverse electromagnetic wave. However, guys, yung transverse electromagnetic wave, pag nag-travel siya in your transmission line, that speed will be lower. Okay? Yun yung tinatawag natin ngayon na velocity of propagation. This refers to the speed of the transverse electromagnetic wave propagating in a transmission line. And always remember guys, na yung velocity of propagation natin is always less than the speed of wave kung nasa free space siya. Okay? So pag nasa transmission line siya, mas babagal. Okay? So kabaliktaran siya ng guys, nung sound wave. Sound wave baliktad eh. Pag sa solid, okay, mas mabilis siya mag-travel kaysa sa free space. In fact, guys, hindi nakakapag-travel ang sound wave sa free space. Okay, guys? So, pakitandaan nyo na. So kapag nasa free space, mas mabilis ang transverse electromagnetic wave. Ang sound wave, hindi siya nakaka-travel sa free space. Pag nasa solid naman, mas mabagal ang transverse electromagnetic wave, mas mabilis naman ang sound wave. Okay? Because a sound wave is a longitudinal mechanical wave. Okay? Ito, transverse electromagnetic wave. So, gaano siya kabagal, no? So it is related to the velocity factor. So ano yung velocity factor, guys? It is the ratio of the actual velocity of propagation divided by the velocity of propagation in free space. So in short, ratio siya ng velocity of propagation and the speed of light. Okay? So that's the velocity factor. Okay, guys? So now, here's the problem gathered from solving. Show that the velocity of propagation in a transmission line can be obtained by this equation. So ito, isa-solve natin siya. Bale, ide-derive natin yung formula. Okay? So, game. Let's do this, guys. So, game. Tirahin natin to, no? First is, ang pinaka-popular example, di ba, nabanggit ko kanina, ng transverse electromagnetic wave is light. Okay? So, let's start this by writing the speed of light. So, ano ba yung speed of light? So, ang speed of light ay c. Okay? So, c, di ba? So, ano nga uli ang value nitong c na to? Yung value niya is 299,792,458 meters per second. Paano nyo po nalaman yun, sir? Galing kasi siya dun sa Maxwell's equation. Okay? So kindly do this in your calculator and tell me ano yung makukuha nyo. So kindly try this one sa inyong calculator and tell me what will be the result. So C ay equals sa 1 over square root ng mu O EO. Okay, so ang makukuha nating value is what? Try it on your calculator, guys. What will you get? Okay, so anong lalabas? Ay, diba? Yan yung sinasabi ko kanina. Yan yung 299,792,458. Nakakasunod, guys? Ayan, so that's the 299,792,458. Now, guys, this one it's because in free space. Tama? Ngayon, pag nasa transmission line na siya, hindi na C yung term natin. VP na. Correct? So, ibig sabihin, dito sa formula natin, ano ang magbabago? So, what will change is instead of mu O, mu na lang siya. Instead of epsilon O, epsilon na lang. Gets? Kasi nasa transmission line na siya. Okay? So, yung nasa free space siya, may mu sub O and E sub O, right? Epsilon sub O. Kasi nasa free space. Now, na nasa transmission line na siya, tatanggalin mo lang yung sub O. Alright? Okay. So, let's rewrite this. Okay. Tinuro ko to sa inyo, guys, no? What will be the expression for this? What's the formula for mu? Diba that's mu sub O, mu sub R, and dun sa epsilon, epsilon O, epsilon sub R. Okay? Now, for transmission lines, what's the typical value of mu sub R? Diba this is 1? Okay, that is 1 because it is about the magnetic property of the material. So pagka may number yan, hindi 1, ibig sabihin magnetic yung material and we don't use magnets no for transmission line. Manipulating this mathematically, anong makukuha natin? So pag minanipulate natin siya, we will get 1 over, square root of, mu O, epsilon O, multiplied by 1 over square root of ER. Okay? Di ba? Maging ganyan. And now, what's this? Right? What's this? Based on sa Maxwell's equation, this is actually the speed of light. So hence, na-derive na natin no, yung formula for the velocity of propagation. So the velocity of propagation is C over square root of ER. Okay? Naintindihan, guys? Nakuha naman? Alright. So that's it. So here's the answer to this problem. But actually, we'll be deriving some more. Okay? Ano ngayon yung implication na nakita nyo? The velocity of propagation, guys, is solely dependent on epsilon r. What is epsilon r, guys? Ano ba yan? The term here is permittivity, but actually, ano yung mas common term na ginagamit natin for epsilon r? That is what ng transmission line. Ano niya yun, no? Yung epsilon r. That's the dielectric, no? Kasi yung yung epsilon r is the dielectric constant. So it's related on the dielectric of the transmission line. So ibig sabihin, guys, no, ano lang ang tanging nagko-control sa speed ng TEM wave sa transmission line. Makikita niyo sa formula, no, na ang tanging ano lang, guys, nakakaapekto sa bilis niya is the dielectric constant or the dielectric. Alright, guys? So, nakadepende sa dielectric nyo. Yung speed nung signal mo as it travels the transmission line. Okay? So, naunawa naman, guys? Nagagets ba? Alright. Now, let's talk about the velocity factor. Okay? So, velocity factor muna tayo, no? So, velocity factor. Ano nga uling definition niya? So, by the definition, guys, the velocity factor is the ratio, okay, VF, it is equal to the ratio of the actual velocity, so BP, divided by C. Okay? So ito yung formula ni velocity factor kung ang pinag-uusapan natin, guys, is the definition. Right? So the velocity factor is the ratio of the speed of light, okay, or speed of the TM wave in the transmission line divided by the speed of light. Okay. But combining the two formula or combining the two equation, so ano makukuha natin? What is the another formula that we can use for the velocity factor? So velocity factor ay equal sa, what is your BP? So that is C all over square root of ER. Do you agree? Divided by C. So ang mangyayari, makakancel yung C natin. So therefore, no, what is our velocity factor? So our velocity factor is 1 over square root of ER. Ayan. So ito yung sinasabi natin kanina, no, sa lesson objective, no, na ang velocity factor actually is based or influenced, no, by the dielectric constant as well. Okay? So huwag niyo kakalimutan yun, guys, no? Alright. Now, let us go back to the Maxwell's equation definition ng velocity of propagation. Okay? So ano nga uli yun? Ito, guys, no? Kunin po natin to. Let's get this one. Okay. So, kunin natin to. Right. So, look at this, guys, no? Look what I will do. So, I will multiply. Okay, I will multiply this. So, yung nasa loob lang mismo, guys, no? I-multiply ko siya, okay, by pi over pi. Yung nasa loob ng square root, Tsaka, multiply ko siya by, ln ng 2s over d. Okay, divided by ln ng 2s over d. So, i-multiply ko siya nito. So, this whole thing, pi over pi times ln ng 2s over d divided by ln ng 2s over d. Anong value niyan, guys? Yung naka-color blue. The value of that is 1, di ba? So, it will not matter, guys. Tama, di ba? Kasi 1 naman yan eh. So, pag minultiply mo siya sa formula, wala namang mangyayari. But notice that the form will change, right? So, ano mangyayari? So, we have VP is equal to, guys? Okay, 1 over, all over, okay, we have square root of, okay, mu sub O, idikit natin doon kay over pi. Oops, what happened? Naging ganun. Naka-ink to shape ako. So, we have mu, okay, tas over pi, right? Over pi. Tapos, kunin mo yung isang ln ng 2s over d. So, you have ln ng 2s over d. Okay, tapos, yung epsilon, kunin mo. So, you have epsilon multiplied by epsilon. Okay, idikit mo sa kanya yung isang pi. So, unahin ko yung pi, So, I have pi here. And then, epsilon. Tapos ito, nasa denominator yung ln ng 2s over d, no? So, divided by ln ng 2s over d. Again, adding the things in color blue, yung nakakulay blue, walang pagbabago yan sa original na equation. Correct? Because the value of the color blue here is 1. However, what the hell is this? Ano to, guys? What is mu over pi ln ng 2s over d. Do you still remember? Ano yan? Yeah, that's the series inductance. How about this one? What is pi epsilon over ln ng 2s over d? That is the shunt capacitance. So therefore, no, another expression natin, no, for VP, no, for a transmission line is 1 over square root ng LC. Okay? And we use this, no, for lossless transmission line. Usually, no, we use this for lossless. Okay, guys? So, nakakasunod naman sa mga nangyari so far. Okay, no? So, meron na tayo 4 na formula. Alright? So, yung sasabi ko sa inyo, guys, no? Yung subject natin, marami talagang mga equation to. Maraming mga formula na ginagamit. Okay? So, kung marami kayong formula na na-encounter sa iba yung mga subject, sa Princoms, sa Digicoms, so, walang-wala yun, no? Walang sinabi yun sa mga equations na gagamitin natin dito sa subject natin. Okay, so we have what? We have already 4. Okay, let's talk about the ano, no? Naalala nyo last meeting, hindi natin to diniscuss. Diniscuss natin is purely attenuation. Let's talk about phase shift. Okay, let's talk about phase shift coefficient. Yung beta, right? So phase shift coefficient, beta, di ba ang formula niya is 2 pi over lambda? Okay, this is 2 pi, okay, over lambda. Yan. So, parang napaka-basic, right? But take note na ito yung sinasabi ko nung introduction sa inyo, na yung lambda natin, hindi siya C over F. Okay? Because the speed at which, okay, the signal travels in a transmission line, it's not C, right? What's that? So, instead of using C over F, tingin nyo, ano gagamitin nating formula for the wavelength? Di ba wavelength C over F? So, what will be the numerator? Yeah, VP. Because that's the speed of the yeah, very good. 'Di ba? VP ang speed niya eh. Now, what is VP? Okay? Yung VP natin, pag titingnan nyo dito, galing dito guys, no? So, lift your answer from here. What is VP? That is CVF. Okay, that is CVF, right? So, equal to sa ano guys? CVF over F. Okay? So, ayan yung formula natin ng wavelength. So yung 2 pi over lambda natin is basically ito. At guys, no, maraming nagkakamali dito, no? And in my experience of teaching this subject, although the students already know this, okay, marami pa rin nagkakamali, no? So ingat kayo diyan, guys. All right? So yung lambda natin is CVF over F. Okay? So if we're gonna edit this one, so that would be yung beta natin. Another expression for beta is 2 pi, okay, 2 pi F, okay, over VP. Right? 'Di ba? Kasi ano no? Ito yung lambda natin. Okay? So pag ni-reciprocal siya, 'di ba ganyan? So that's another expression for what? Another expression for our beta. So 2 pi F over VP. Yan, so medyo padami na ng padami, no? And finally, guys, no, our last topic here is the phase shift. Naalala niyo yung last week, no? So pinag-usapan natin yung attenuation lang. So pag phase shift, paano kaya yung formula niya pag phase shift lang? Hindi phase shift coefficient, ha? Phase shift lang. So yung phase shift lang, that is phase shift equals beta multiplied by the length. Di ba? Basic, no? So parang ano, no? Let me show you, no, yung last time. Ito, di ba? Saan yun? Wala na. Ito, di ba guys? Kung attenuation, that's alpha L. So kung kailangan mo phase shift, that's beta L. Okay? So, very intuitive naman, di ba? Kasi phase shift coefficient, per meter yon. So, kailangan multiply mo ng length. Now, let's study this one, no? Okay. Ano nga uli yung beta? So, yung beta natin is 2 pi F, right? So, that's 2 pi, okay, F, okay, over VP. Multiplied by the length. Alright? Ngayon guys, isipin nyo na ito yung transmission line mo. Okay, so this is the length of your transmission line. And your signal will travel from here to here. Papunta dyan. At the speed of VP. So, ano na lang yung missing parameter, guys? So, meron ka ng length, meron ka ng speed. Okay, ano na lang yung nawawala? Galing sa basic na physics. Meron kang speed, meron kang length. Ano na lang yung kulang na parameter? Basic na time, very good. Right? Time, di ba? Oo. And basically, time is length over VP. I mean, distance, di ba, ang time, formula ng time, ano nga formula ng time sa basic na physics? Time equals distance over the rate. Okay? So, and distance mo ngayon dito is L, and yung rate mo is VP. So, ibig sabihin, no, this thing here is actually the time. Right? So, another formula that you can use no, for your phase shift, okay, is 2 pi ft. Okay? Ayan, no? So, grabe ang ano, no? Development ng mga ano, no? Formula natin. Parang yung meme, no? Escalated quickly. Okay? So, dumami na. Ayan, yan. Di ba? So, medyo madami-daming mga equations, no? Ang kailangan yung, ano, matutunan at tandaan. Alright? Okay, so that's it, no? For this one. So, actually, lahat ng dinerive nating mga equations, nandito naman yan, no? Nandito naman siya sa, ano natin, sa slide, no? Naka-summarize naman siya. By the way, dito ginawa ko na instead of 2 pi ft, yung 2 pi f kasi is omega. So, omega yung nilagay natin. Okay? So, game ready na? Solve na tayo ng problem? So far guys, nakakasunod pa ba? Nagagets naman yung pinagagawa natin so far? Everyone? Are we on the same page? Nice, good. Okay, game. Let's do this. Let's answer this guided problem solving. So for a lossless transmission line with L equals 40 microhenry per meter and C equals 20 picofarad per meter, solve for letter A, the velocity of propagation, letter B, velocity factor, letter C, beta for 750 megahertz operating frequency. Okay? So, game Let's do this, guys. Let's do this. All right. So, here's our problem. Okay, first, we are asked to solve for VP. Napakadaming formula ng VP kanina, guys, no? Ano yung pinaka-applicable? What do you think? Yung pinaka-applicable na gamitin sa VP. Maraming formula na nandun sa kabilang no, page. But what do you think is the most appropriate? No? So gagamitin natin yung for, yeah, very good. Yung pang lossless. So 1 over square root of LC. So 1 over square root ng, ano yung L natin? 40. So 40 times 10 to the minus 6. Okay? Multiplied by, ano guys? 20 times 10 to the minus 12. Okay? Sige guys, game. Yan. Yun lang wala ko guys. No, I don't have my calculator with me. So kindly help me in that area. So what is V sub P? Diba madali lang naman talaga yung ano natin no? Madali lang talaga yung ano natin, subject natin. Okay, so kailangan lang alam niyo talaga yung formula. We have 35 point, ano yun? 36. Okay, 36 times 10 raised to 6 meters per second. Okay? Okay, next. Okay, VF naman, velocity factor. Again, we have many equations na we can use no for the velocity factor. What do you think is the most appropriate in this case? So, anong gagamitin natin for the velocity factor? So, I think yung definition, no? Oh, yung definition yung pinaka pwedeng gamitin, VP over C. So, this is simply equal sa 35 times 35.36 times 10 to the 6. Okay, divided by 3 times 10 to the 8. Okay, so what is our velocity factor, guys? So madali lang no yung ano natin. Oh, mga calculations, 'di man sobrang hirap. Okay, we have point. Ayan. So, you would know guys na kung tama o mali ang sagot nyo dito because the speed of light is the fastest, no? Okay, alam nyo ba yon? Sa theory of relativity, nothing can be faster, no? Than the speed of light. So, ibig sabihin, ang velocity factor mo dapat less than 1 palagi. Once you obtain a velocity factor greater than 1, something's wrong with your calculation. Okay, guys? So, maliwanag ha. Ang velocity factor natin, always less than 1 po yun. Okay, next is we need to solve for beta for 750 megahertz. So, game, letter C. Okay, so ano nga ulit formula ng beta, guys? That's 2 pi over lambda. But I think we can use yung 2 pi f over VP. I think this one is more appropriate, right? Tama. Okay, so what is 2 pi? 2 pi lang. What is f? 750. 750 times 10 to the 6. Okay, divided by the velocity of propagation, which is what? Nakompute na natin yun, di ba? Ayun, 35.36 times 10 to the 6. Okay, guys? All right, so kindly help me, no? So what's the value for beta? Okay, we have 133 point, what? 133.269. Okay, what's the unit? Yan, baka nalimutan na. Anong unit niyan, guys? Ni 133.269. So what's the unit, guys? Okay, radian per meter. Very good, no? So radian per meter, that's the unit for the uh tawag dito, phase shift coefficient. Naghang eh, no? Okay, tawag natin dito, phase shift coefficient. Okay? So, everything clear, guys, no? For the velocity of propagation. So, yun lang naman yun, no? Yung mga tatandaan yung mga calculations with regards to that. Alright? Okay. So, I think we can now move on sa next topic natin. Okay. So next topic natin is a very interesting one. Okay, ang tawag natin dito sa topic na to ay reflection. Okay? So, ganito, 'di ba? What's the main requirement, guys, no, for maximum power transfer in a transmission line? Ano yung pinaka main requirement natin na dapat masunod to ensure that we will achieve a maximum power transfer? So, what's the requirement, guys? Naalala niyo pa? What's the requirement for maximum power transfer? Dapat, yeah, very good. Dapat the characteristic impedance ay equal, guys, sa load impedance. Okay? So, na-discuss na natin yun, di ba? I know na natatandaan niyo pa yun, no? Okay. So, ZO is equal to ZL. That's the main requirement. But what will happen pag hindi yun nasunod? No? So, what will happen if it's not the case? Okay? In the event that the transmission line is not terminated with a load impedance equal to the characteristic impedance, what will happen is reflections will occur. Okay? So, the idea here is to transfer everything, no, from the source towards the load. But in the event that ZO is not equal to ZL, not all the power will be absorbed by the load. Some power will be reflected. So, ibig sabihin, guys, no, dalawa ngayon yon, no? Tinatawag nating ano ngayon? We call that as the transverse. We call that as the incident wave. Yung incident wave, guys, is yung direction niya is mula sa source papuntang load. And on the other hand, kapag mula sa load pabalik sa source, reflected wave naman. Okay, guys? So may pangalan na, no? May terminology na tayo, no? So incident wave is from source towards the load, tapos kabaliktaran naman, no? Load back towards the source, that is reflected wave. Okay. Okay. Now guys, here's the thing. Gaano kadaming signal ang nagre-reflect? Okay? So, gaano kadaming signal ang nagre-reflect? Lahat ba? Kalahati? 1/4? So, how do we know, no, the amount or the magnitude, no, of the reflected wave? So, paano natin malalaman yun, guys? No? Kaya alam natin na ZO is not equal to ZL, no? Kasi pag ZO equal to ZL, wala kang reflection. But in the event that ZO is not equal to ZL, magkakaroon tayo ng ano guys? Magkakaroon tayo ng reflection. So yun na, doon na nga papasok si incident wave tsaka reflected wave. Now the question is, how will we know, no? Gaano kadami yung magre-reflect? Kalahati ba? 1/4 ba? 1/3 ba? Lahat ba magre-reflect? How would we know, guys? So gaano kadaming signal ang magre-reflect? I mean, kasi some of the power will be absorbed by the load and some of the power or the energy will be returned back to the source. So gaano kadami, no, yung nire-return? Tingin nyo guys. Kalahati ba? 1/4? Again, the reflection is because ZL is not equal to ZO. Okay? Kasi pag equal sila, walang reflection. So yun na nga, hindi nga sila equal. So how would we know, no? Gaano kadami, no? Reflected wave ang babalik. Okay? Difference ng ano guys? Difference ng? What do you mean by difference? 'Di ba? Gaano kadaming reflected wave, no? So depends on the ratio of ZO and ZL. Mhm. Mhm. Okay? Anong difference? Malapit doon sa difference eh. Difference ng ano yung tinutukoy mo, Chukiti? Difference ng tsaka ni ano, no? Ni Papa Bear. Ayan. Ang ano eh, takang-taka si Papa Bear sa buhay. No? Tatlong question mark pa talaga. No? Difference? Parang ganun eh, no? Imagine ko si Papa Bear in real life, no? Oh, ano yung difference na yun na sinasabi niyo? Malapit na dun yung tamang sagot, no? Difference ng ano yan, Papa Bear and Chukiti? Difference of what? Difference ng? Okay, no? Si Yorlin na lang ang sumagot, no? Difference ng ZL and ZO. Okay? So, actually, it's close, no, to that, no? So, it depends on what? It depends on what we call as the reflection coefficient. Okay? So, yung reflection coefficient, guys, no, it is a vector quantity that gives, okay, the ratio of the reflected voltage tsaka incident voltage. So by the way guys, no, pag reflected, ang symbol natin doon ay minus, kaya E minus. Tapos pag incident voltage naman, E plus. So if you get the ratio of that, you will get the reflection coefficient. Pag cross multiply mo yon, na-imagine nyo guys, hindi ko kasi nalagay. Imagine nyo na lang, no? Ito ang hirap sa online class eh, no? Imagine dapat eh, no? Kuya rin nakalagay ito dito. So ang makukuha nyo is E minus equals reflection coefficient times E plus. Diba? So from there, you would know how much, okay, how much of the incident voltage will be reflected. Now, ano yung formula ni reflection coefficient? Ayun, no? Kita nyo guys, sa numerator, nandun yung difference, no? ZL minus ZO. Pero not really the difference, no? It has something to do with the ratio as well. So, divided by ZL plus ZO. Okay? So, nagagets guys? So, bale, tama naman, difference. Tama din na ratio, no? Pero, pagsamahin niyo yung mga sagot nyo, you will get the correct answer, no? So, the reflection coefficient, ano ang formula niya? Z sub L minus Z sub O divided by Z sub L plus Z sub O. So, pag nakuha na natin yung reflection coefficient, halimbawa, reflection coefficient mo is 1/4. So, ibig sabihin, 1/4 ng signal ang magre-reflect. Okay, guys? Maliwanag po ba? Is everything clear with regards to the reflection coefficient? Okay. So, ang palatandaan ko dyan guys, para hindi ako malito, lolo, no? Yan, lolo formula. Kasi L-O, lolo. Okay? So, game. Let's try to answer the guided problem solving question. Alright, no? So, a communication system uses an RG58U transmission line terminated at a load impedance of 50 minus J25 ohms. Determine the reflection coefficient. No? So, we just use the formula for the reflection coefficient. Okay? So, ZL minus ZO divided by ZL plus ZO. So, yung ZL natin is 50 minus J25. Okay, minus Z sub O. Ito yung sinasabi ko guys, no, hindi na po binibigay madalas ang value kapag binigay na yung type ng cable, no? So, by the way, anong klaseng transmission line to? Pag RG58U, that is a coaxial cable na may characteristic impedance na ano guys, that is 50 ohms. Okay? So, bale, minus 50 divided by Okay, quantity 50 minus J25 plus 50. Okay? So what will be our reflection coefficient? Ah, ganito guys sa reflection coefficient, dapat ang answer natin laging naka-polar form. Alright? So kahit na tama yung sagot nyo pero naka-rectangular form kayo, no, mamalian natin yan, ha? So make sure guys that your answer is in polar form, no, kapag ang tanong is reflection coefficient. Okay? So yun yung ating convention, no? So please adhere, no, to the convention. So ano lalabas guys, by the way? Anong makukuha natin? Okay, so we have 0. Okay, 243. Okay, var angle, negative 75.964 degrees. Okay? Unitless to, no? Because this is a ratio. So, unitless siya. That's our answer. So, it means, anong ibig sabihin nito? Ibig sabihin nito, guys, na 0.243, around 24%, no, of your signal will be reflected with a phase shift of negative 75 degrees or negative 76 degrees approximately. So, na-guess nyo, guys? Ganun yung reflection. No? So, bali, 24% ng signal mo, kunyari 100 watts yung pinadala mo, you will be receiving back 24 watts na phase shifted ng negative 76 degrees. Okay? So, naintindihan na guys? Nakukuha naman? Alright. So now, let's talk about this one. Let's try to solve this. So solve for the reflection coefficient if a transmission line, okay, is terminated with letter A, short circuit, letter B, open circuit, and letter C, a load impedance equal to, say, sub O. Actually, ang tawag natin dito ay mga special cases. Okay, so special cases ng reflection coefficient. So let's talk about this. Okay, so for part A, okay, anong sabi rito, no? Yung transmission line daw natin is terminated with a short circuit. Okay, so kunyari ito yung ating source. Ito yung generator natin. And then, ito yung ating transmission line. Ano? Yan. So pag sinabing terminated with the short circuit, anong ibig sabihin nun? So dito, shorted siya. Yan. So what will be the reflection coefficient? So ano ang ZL kapag shorted? What will be the value of ZL for a shorted transmission line? Shorted, ano? Yeah, 0, di ba? Pag shorted, 0 yun. Okay? So, apply natin yung formula ng reflection coefficient, no? So, ZL, okay? Hindi ko nasulat yung formula, no? So, yung ZL natin ay 0. So, 0 minus ZO, okay, divided by 0 plus ZO. Okay, what will be the result? That is negative 1. So, a reflection coefficient natin, pag short circuit pala, is negative 1 or, ano guys, 1 var angle 180 degrees. Okay? So, naintindihan guys? So, anong implication nito? The implication of this is, if you have a shorted, okay, transmission line, ang mangyayari, anong ibig sabihin guys ng negative 1 na reflection coefficient? What does it mean? Anong implication yan guys? Tingin nyo. Di ba na-compute natin, no? So we have negative 1, right? So ano ibig sabihin ng negative 1, no? In the context of reflection. It means that what? It means that, okay, lahat, yeah, very good, no? Lahat ng pinadala mong signal, yes, reflected lahat, babalik lahat. Ano ibig sabihin ng negative? So babalik lahat pero phase inverted. Okay, so halimbawa guys, no, ito yung signal na pinadala natin. So let's say we sent a pulse. Okay? Nagpadala tayo ng pulse. Tapos, anong nangyari guys is same, no? Same magnitude will be returned. Pero, phase inverted. Gets you guys? So, lahat ng signal mo, oops, nawala lahat. Lahat ng signal mo babalik, okay? pero merong phase inversion na involved. Okay, naiintindihan guys? So yung kulay blue, yun yung incident. Okay, tapos yung kulay red yung reflected. Okay? So pag shorted pala, no, all of your signal will be reflected back to the source. Phase inverted. Alright? Okay. So that is for letter A. So for letter B, guys, no? Okay? So for letter A kasi ang Z sub L natin is equal to 0. Okay? Because shorted. So pag open, guys, anong ZL natin? Di ko na ito drawing, ha? Pero what is our Z sub L kapag open? Open circuit kasi yung letter B, eh. Right? So what will be our Z sub L pagka open circuit? Okay, infinity, right? Yeah, very good. So infinity. So let's rewrite the formula of the reflection coefficient. We have ZL minus Z sub O divided by ZL plus Z sub O. So i-multiply natin to guys by, okay, 1 over ZL divided by 1 over ZL. Okay, so what will happen is, magiging ganito siya, no? 1 minus ZO over ZL divided by 1 plus ZO over ZL. But the value of ZL is infinity, no? Kasi nga open. So this is infinity. Okay, so this is infinity. So what's the, anything divide by infinite, guys? Ano ang answer? Anything divide by infinity, what will be the answer, guys? Okay, di ba? Imagine, no, may pizza ka, tapos hinati mo siya infinitely many times. Di ba? Mapupulbos yun, mawawala. Di ba? Okay, no? So parang, di ba? Okay, so pag hinati mo yung no, hinati mo yung pizza, no, infinitely many times, pulbos na lang. O di wala ka nang nakain na pizza. Alright? So the value of this shit is 0. This is 0 as well. Okay, so 1 over 1, we will get 1. So therefore, the reflection coefficient natin kapag open circuit is 1 or 1 var angle 0 degrees, no, if you may. So what do you think will be its implication naman? Di ko na siya ida-drawing, guys, no, but what do you think will be its implication? Ano ang ibig sabihin na reflection coefficient na positive 1 or 1 var angle 0 degrees? What does it mean? Anong ibig sabihin yan? In the context of what we have learned earlier. So kapag open circuit, mali. Oo. Ang ibig sabihin nun, babalik lahat pero hindi inverted. Okay, guys? So pag open circuit, no, so babalik lahat pero hindi inverted. Pag short circuit, babalik lahat, okay, pero inverted. Okay? Hindi mali, hindi po walang na-reflect. Ingat ingat sa ganun, maraming nalilito, no? So ang ibig sabihin ng 1, reflected pero hindi phase inverted. Okay, reflected lahat pero hindi phase inverted. Okay? So, wag po malito. Minsan nakakalito talaga. So ingat kayo, guys, ha? All right. So, let's talk about the third situation. What's the third situation, guys? According sa problem, the third is yung ating load impedance, or I mean the transmission line is terminated with a load impedance equal to ZO. Okay? So for part C, guys, we're asked to solve what if ZL is equal to ZO. Okay? So anong makukuha natin? Reflection coefficient equals ZO minus ZO divided by ZO plus ZO. Okay? ZO minus ZO is 0, of course. Okay, divided by 2 ZO. So ano lalabas, guys? What is our reflection coefficient? 0. Okay? Yan. So what's the implication of this naman? If your ZL, if your load impedance is equal to characteristic impedance, what will be the reflection coefficient? 'Di ba 0? So yeah, very good. Iyan yung sagot dun sa iyan yung walang reflection. Okay, lahat ng power inabsorb ng load mo. Walang nag-reflect. Okay? So naintindihan, guys? Nagets naman? Okay. So now, ibig sabihin, no, what do you think is the ideal, okay? Ideal reflection coefficient. Kasi matanong kayo guys, no? Ano bang gusto nyo? May reflection o wala? Which is better, no? A transmission line system with reflection o yung wala? Tingin nyo guys. Mas maganda yung wala. So ibig sabihin, no, pag tinanong kayo, no, what will be the ideal reflection coefficient? So anong ideal? Zero. Okay? Maraming nagkakamali dun guys, no? Kahit napakasimple niyang isipin. Yeah, oo. Zero. Okay, zero, zero. Tama, very good. Okay. So now let's talk about not the special case but rather the typical, I mean the common, no, na nangyayari sa reflection. Special case lang to, no? But in reality, most of the time, no, the reflected, okay, signal is always what? The reflected signal is always smaller than the incident signal or the incident wave. Tandaan nyo yun, guys, ha? 'Di ba yung incident natin yung color blue, okay? Tapos yung color red natin reflected. In most cases, guys, no, the reflected wave is always smaller. Okay? In most cases. Okay? Nagagets ba? Okay? Now, they will travel on the same transmission line. No? They will travel on the same transmission line. So parang ganyan, no? Yan. Okay? So yung color blue, that is your incident wave, and yung color red, that's your reflected wave. Okay? So ngayon, no, naalala nyo pa, di ba? Diniscuss natin yung mga transmission impairment. Anong transmission impairment yung ano niyan? Dinedescribe niyan? Na meron kang dalawang legit na signal sa isang channel. Anong transmission? Yeah, that's what we call as interference. Correct? Yeah, very good. Kasi yung pula, di naman noise yan, right? So yung pula is a legit signal na reflect back nga lang. So ngayon, nagkakaroon ngayon ng interference, yung incident wave tsaka reflected wave. So yung interference na yon, anong tawag natin doon? Yun yung next topic natin, guys. No? That is the, what? That is the standing wave. Okay? So standing wave is essentially the interference pattern that is set up by the reflected and incident wave. So that is the standing wave. So in this, guys, color blue is the incident, color green is the reflected. So pag yung dalawa na yon nagkakaroon ng interference, guys, you will not actually see two different waves, no, on your transmission line. What you will see is yung kulay black, the standing wave. Since periodic ang incident wave tsaka reflected wave, periodic din ang ating standing wave. May mga points kung saan mataas ang value niya at may mga points na minimum naman yung value niya. So, now we can actually get its ratio, no? Yung ratio ng maximum voltage tsaka minimum voltage ng standing wave. At yun yung tinatawag nating standing wave ratio or VSWR. Okay? So VSWR, guys, is the ratio of the maximum voltage tsaka minimum voltage ng isang standing wave. Bakit mahalaga ang standing wave ratio? Okay, standing wave ratio, mahalaga siya because that is actually the measure how how mismatch, okay, your load impedance to the characteristic impedance. So the idea here is the higher the value of your SWR, the more mismatched, okay, your transmission line system is. Kaya nga naka-highlight dito, guys, no, that the ideal value for the SWR is 1 and the ideal value for the reflection coefficient is 0. Kasi kung SWR mo, guys, is equal to 1, meaning match ang characteristic impedance sa load impedance. So in your screens are the different equations or formula that we can use, no, for the SWR, no? So mga iba't ibang mga formula, guys, no, ng SWR. Meron lang ako hindi na isulat na isa, i-discuss ko siya later, no? But yeah, ito yung mga equations, no? You can refer to this, no? Kapag magsasolve ka ng mga problem. Okay? Ito yung mga equation natin for the relationship, no? I mean, equation natin for the SWR. Yung SWR, by the way, kaya may V sa unahan because that is for voltage, no? Voltage standing wave ratio. So, ibig sabihin, sir, pag walang V, okay, voltage pa din yun. Alright? So, miski may V, miski walang V, ang SWR mo is V max over V min. Alright? So another, kasi meron ding ISWR. Pag ISWR, I maximum over I minimum. Alright? But almost exclusively, no, ang pinag-aaralan natin with regards to SWR is the VSWR, the voltage standing wave ratio. Okay? Alright. I think it's much better if we solve a problem para mas magets na siya. Right? Let's try to answer one. Okay, but before that, no, so sorry, I forgot. No, so solve natin guys, no, yung hindi ko na ilagay na formula. Okay? Gato kasi yun eh, no? From the definition, ang VSWR is equal sa ratio ng Vmax sa Vmin. Vmax tsaka Vmin ng ano to, nung standing wave. Okay? Tingnan nyo guys, no? Kailan magiging maximum yung value ng standing wave? Magiging maximum yung value ng standing wave mo kapag ka doon sa point guys na in phase yung reflected wave tsaka incident wave. So meaning to say, in formula, that would be E plus E minus, yung magnitude nila. Nagets? Naintindihan? Alright. And the minimum value naman will occur kapag ka out of phase, no? Yung ano natin, yung dalawa. So yung minimum value nito is basically equal saan? So that would be E plus minus the magnitude of E minus. Okay? So yan yung hindi ko po naisulat na formula, no? Kanina. I mean, hindi natin nailagay sa slides. So please also consider this one. Okay? Actually, dyan na-derive yung isang formula na ginagamit natin, no? Yung 1 plus the magnitude of the reflection coefficient divided by 1 minus the magnitude of the reflection coefficient, no? So dyan po na-derive yung formula na ginagamit natin madalas. Galing dito. Alright, guys? Okay. So I think we are now ready, no, to solve this problem. Game? Everyone? Let's do this? Yes. Let's read. A communication system uses an RG58U transmission line terminated at a load impedance of 50 minus J25 ohms. Determine the SWR. Actually, we have solved this one earlier, right? So yung RG58U natin is may Z sub O na 50 ohms. Okay? So let's just copy the solution, guys, no? Let's just copy this for the reflection coefficient. Okay, so yan, kinopya ko lang guys, no? Right. Pero hindi yan yung tanong, no? Ang tanong is SWR. So how do we solve for the SWR? So for the SWR, we will use one of the equations there. Ano nga uli yun, sir? So yung SWR natin ay equal guys sa 1 plus the magnitude of the reflection coefficient divided by 1 minus the magnitude of the reflection coefficient. So, wag magkakamali Maraming nagkakamali dito, guys. Pag sinolve mo to, ang ilalagay mo 0.243 lang, ha? Hindi po kasama yung var angle over 1 minus 0.243. Okay? So, what will be your SWR? What will be your standing wave ratio? Sige guys, pakitulungan nga ako. So, you need to solve for the reflection coefficient first, no? And pag na-solve mo na siya, just get the magnitude and yan, solve for the SWR. Okay? We have 1.642. Alright? So, nauunawaan guys? Nakukuha naman? Okay. So, this is your ZL by the way. Okay, so I would just like to emphasize a formula that is written on the slides. May formula doon ng SWR na ang nakalagay ay ZO over RL. Tsaka may isa pa na SWR is equal sa RL over ZO. Parang ganyan. Ano ba yung RL tsaka ZL na yan? Actually guys, itong RL, okay, at ZL na to, no? They mean what? They are actually load impedance as well. So you can just simply divide. Okay, you can just simply divide the load impedance by the characteristic impedance or vice versa to get the SWR, provided that they are purely resistive. Okay, nagegets? Kaya I specifically use the symbol R, okay, instead of Z, because you can only use no etong dalawang formula na to, no, in the event that ano guys, yung ZL mo is purely resistive. In this case kasi guys, it's not, right? 50 minus J25 ohms is not purely resistive. So that's why nung sinolve natin siya, dumaan pa tayo sa reflection coefficient before we are able to solve for the SWR. Okay? Nagagets ba? Alright. Sir, ba't dalawa? ZO over RL. Yung isa RL over ZO. When to use one from the other? So, tatandaan na ang SWR dapat laging greater than or equal to 1. So, if you get the ratio, sometimes kasi mas malaki ang ZO kaysa sa RL and sometimes mas malaki yung RL kaysa sa ZO. Just divide the two resistances and get kung ano yung mas mataas. I mean yung greater than 1 na value. Naintindihan ba? Kumbaga, you're gonna use the first formula if ZO is greater than RL. You're gonna use the second formula if RL is greater than ZO. Okay? I hope that's clear, no? But the thing is, itong dalawang formula na to, magagamit mo lang kung ang load impedance mo ay purely resistive. Pag hindi, you need to go through this one, no? You need to solve for the reflection coefficient first and then solve for the SWR. Actually guys, kahit na purely resistive, you will get the same answer if you get the reflection coefficient first and then the SWR. Kumbaga, kahit hindi mo gamitin tong dalawang formula na to, okay lang. Right? Kahit di mo yan gamitin, no? So, kahit na wag mo siyang gamitin, you can still get the SWR if you will do this procedure. Reflection coefficient first and then SWR. Okay, so I still remember, no, there are a lot of students na confused dito, no? Kasi very basic yung SWR 0 over RL eh. I mean, divide mo lang, makukuha mo na yung SWR. Little they know that the load impedance has an imaginary part. So pag may imaginary part yon, hindi pwede, guys. Right? So, maliwanag po ba? Nagagets naman? Nakukuha po? Hello, guys. Nakukuha naman. Everyone. Naintindihan? All right, no? Okay. So, I think we're now ready, no, to solve the next problem. Okay, power relationship, no, sa isang transmission line. A transmitter supplies 50 watts through a line with an SWR of 2:1. Okay, what is the power absorbed by the load? Okay, so for this, we need to investigate the formula for the reflection coefficient via its definition. So yung reflection coefficient natin, guys, ang formula nito, kaya magnitude lang ang kailangan natin, is simply the magnitude of the reflected voltage over the magnitude of the incident voltage. Tapos, in-square natin. Sir, bakit mo po in-square? Kuyari, wala ka nang magawa. Isang araw na pag-decidean mo, square ko nga to. Ganun, no? Okay. So, wala kang magawa, no? Na pag-decidean mo lang, isang araw, square ko nga to. Walang ganun, no? Walang magawa, no? In-square mo lang basta. Ayan. So, naka-square na to, no? Tapos, ito, pagka-square mo sa kanya, dinistribute mo yung square. So, parang E minus square. Tapos, dinivide mo by R. So, yung denominator, ganun yung ginawa mo din. Reflection coefficient, I mean, incident voltage, square divide by R. So, nothing will happen, guys, di ba? The value will not change because dinivide mo yung numerator by R, dinivide mo rin yung denominator by R. So, okay lang. Now, what is this, guys? No? Ano yung kamukha nitong formula na to? Yung voltage, tas di-divide mo by R, by resistance. Same goes with this. Voltage, di-divide mo by resistance. What's this? Ano yung voltage square over R? That's power, right? Yes. So therefore, we can now get the power relationship. So the power relationship is simply the voltage reflection coefficient square, okay, equal to dun sa power reflected, okay, divided by power incident. Okay? So in short, guys, no, the reflected power ay equal sa magnitude ng reflection coefficient na naka-square multiplied by the incident power. Okay, so another equation ulit, guys. Alright? Nagets naman so far yung pinagagawa natin? Alright. So, commercial lang to, no? Hindi pa talaga to yung problem. Dinerive lang natin yung formula na gagamitin. Oops. Okay, let's solve the actual problem, guys. Right, sabi daw, meron ka daw transmitter na nag-transmit ng 50 watts through a line na may SWR na 2:1. So let's say ito yung ating generator and this is our transmission line and then may load impedance tayo. Hindi nakabigay yung value, no, ng ating load impedance. Okay. Pero tingin nyo, guys, in this problem ba, yung load impedance ba equal sa characteristic impedance o hindi? Tingin nyo, guys. 'Di ba may characteristic impedance din tayo dito? So is the load impedance equal to the characteristic impedance in this case or no? They're not equal. What do you think? Equal ba yung load impedance sa characteristic impedance? Okay. So, hindi? Okay, why? Bakit hindi equal? Tama, hindi sila equal. How do you know na hindi sila equal, guys? Oh, bakit hindi? Oh, yeah, oo nga. Hindi nga. Bakit hindi? Paano niyo nalaman na hindi sila equal? Ano ang indicator nyo? Okay, no? So the main indicator here, guys, is the SWR. Okay? Remember, no? SWR is a measure of degree of mismatch. Naintindihan? Degree of mismatch. So, if your SWR is 1, meaning match, equal lang ZO sa ZL. But if your SWR is any number that is greater than 1, so automatic, guys, hindi na match yung ZO tsaka ZL mo. Okay? Naintindihan, guys? Because ang SWR is a measure of mismatch. So if your SWR is not equal to 1, automatic hindi na match ang transmission mo. I mean, hindi na match yung characteristic impedance kay load impedance. So if that's the case, magkakaroon tayo ngayon ng guys? Magkakaroon tayo ngayon ng incident power. Dahil hindi siya match, definitely, meron tayong reflected power. But of course, not all the power will be will not be reflected, no? Some power still would be absorbed by the load. So P-abs. Now, based on this, no, can you give me an expression for P-abs? Ano yung expression natin for the absorbed power? Based sa drawing natin, guys. What do you think is an expression for absorbed power? P incident yung pinadala mo, 'di ba, mula sa source towards the load. Tapos yung reflected is mula sa load back to the source. So, what do you think will be the equation or expression, no, for the absorb? So, that is basically P incident minus P reflected. Very good. So, P incident minus P reflected. Okay. So, that's easy, right? However, meron tayong formula ng P-rep, no? Na yung nga yung dinerive natin kanina. So, yung P-abs natin, therefore, pwede nating palitan ngayon ng guys? Okay, P incident, okay, minus the magnitude of the reflection coefficient square multiplied by the P incident as well. And then we can factor out P incident to get an equation for the absorbed power. So absorbed power is basically equal sa 1 minus the magnitude of the reflection coefficient square, okay, multiplied by the P incident. Okay? So formula na natin yan, guys, no? Okay? So, game. Tirahin na natin guys. Kayang-kaya na to. So, ano yung incident dito? Pag binasa niyo yung problem, ano yung incident power natin dito? Incident power natin is what? Okay, yun yung 50 watts, di ba? Bakit yun? Kasi yun yung supply. Yun yung sinupply. Kaya lang wala pa tayong reflection coefficient. So we need to solve for the magnitude of the reflection coefficient. So saan manggagaling yun? Dito sa formula natin ng SWR. So SWR is equal sa 1 plus the magnitude of the reflection coefficient divided by 1 minus the magnitude of the reflection coefficient. So if our SWR is 1/3, okay, 1 over 3, ay 1/3 tuloy. Sorry guys, 2. Okay, so advance kasi ako mag-isip. Makikita nyo bakit. We have 1 plus the magnitude of reflection coefficient over 1 minus the magnitude of the reflection coefficient. So therefore, so what is the magnitude of the reflection coefficient? Oh, yan yung 1/3, ha? Okay, sorry guys kanina. Right? Mhm. So we have 1/3 here. Substitute lang natin 1 over 3. Okay? So what will be our P-abs, guys? Naka-square, sorry. Naka-square. And don't forget to square. Okay? So, naka-square, sorry. Naka-square. Okay? So, we have what? Okay, we have 44.44 watts. Okay, so what does it tell us? Anong implication nito or ano yung nagets natin from here? Ang pinadala mong power is 50 watts. Ano lang yung na-absorb ng load mo? 44.44. Okay? Nagets niya, guys? So, in a sense, may loss. Hindi naman siya loss pero ang nangyari, nag-reflect siya. Okay? So, parang hindi na yon nagamit or na-utilize ng load mo. Okay? Nagets ba? So, kumbaga, in the transmission, no? So, meron kang around, how much is that? 5.6, di ba? 5.6 na hindi na-utilize ng load mo. Alright? Okay? So, yan yung implication or yan yung nangyayari if ZO is not equal to ZL. Alright, guys? You understand now? Alright. So, actually, may isa pa tayong formula, no? May more direct formula tayo that we can use for this one. Okay? So, ano yung more direct na formula na yon, no? So, we can use this one, guys. Mas madali ito gamitin. Okay? So, hindi pantay yung arrow ko. Shrink. Aka-OC tignan no? Alright, no? So, ano yung formula natin, guys, no? Ano yung formula na yon? We can use this one. So, we have the absorbed power, okay, ay equal sa 4 times the SWR, alright, divided by, okay, the quantity 1 plus SWR, quantity square, multiplied by the incident power. Okay? We can actually use this formula and it's easier, pag ito yung ginamit mo. Very convenient kasi napansin nyo guys, 'di ba, nag-solve pa tayo kanina ng nag-solve pa tayo ng ng reflection coefficient. Ito given na SWR, 'di ba? So SWR mo 2:1, so 2 over 1. Okay, divided by 1 plus 2 over 1 quantity square times 50. So, do we get the same answer if we use this formula? Okay, so we get the same, right? Tama ba? Paki-verify nga, guys. 44.44 pa rin. Okay. Ayan. Yung mic. Paki-mute yung mic. Yan. Thank you. Okay? So, mas direct siya, no? Oh, what do you think is the problem in this formula? Although very convenient siya. So, what's the problem with this one? Tingin nyo. Dito kay 4SWR over 1 plus SWR something. What do you think is something, hindi naman wrong, no? But ano masabi niyo with this formula compared doon sa isa? Ayan, same lang naman din nakuha, no? So you can use both. Kaya lang dito guys, may additional step pa. Ito pag SW yung given, matik na. Tingin nyo, anong ano nito? What's the issue, no, with this one? In this formula, guys. What do you think? Magagamit siya. Magagamit siya kahit SWR mo ay 1. Okay, magagamit siya kahit SWR mo ay 1. Actually, maganda nga to eh. Kasi mapapatunayan mo guys na pag SWR mo ay 1, ang absorb mo equal sa incident. Pansinin nyo guys. If your SWR is 1, so mangyayari is 4 times 1 divided by 1, bale 1 plus 1 square. So parang 4 over 4. Di ba? So P abs equals P incident. Tama? So, 'di ba, mas maganda siya eh, no? Kung SWR mo ay 1, you can actually see that P abs equals P incident. All the power is absorbed by the load. Okay, sir, paano nakuha yung formula? Dinerive natin yan. May derivation yan, guys, no? But that's not the issue right now. Oo. The issue right now, guys, is napakadami nyo ng formula, no, na ano, i-memorize. Di ba? And this one is quite complicated, okay? Kumpara do sa isa. This one is very straightforward, no, from the derivation. 'Di ba? Dito, yun nga kagaya ng tinanong ni ano, 'di ba? Iba talaga pag si Pababer, no? Ang mga tanong ni Pababer very enlightening eh, no? So, yung tanong ni Pababer, no, hindi natin alam paano nakuha yung formula. 'Di ba? So, maaaring makalimutan nyo. Tama? 'Di ba? Ito kagaya ng isa, very intuitive yung pagkuha natin. Okay? Ayan. So, ganun eh, no? And marami pa tayong mga equations or formulas na gagamitin na mapag-aaralan sa subject natin. Alright, so nagets nyo? No? So, ayos lang. Ayos pa kayo dyan. Okay pa kayo dyan, guys. Ayos lang. Yes? Yes? Okay pa kayo? Kaya pa ba? Okay pa. Okay, no? So, ganito. Nakita niyo yung mga formula natin, no? So, may mga simple, may mga complicated. This one is a little bit complicated and hindi intuitive, no? Kagaya nung kanina. 'Di ba? Sabi nga ni Pababer, paano po nakuha yung formula, sir? Yung formula kasi kanina, kaya i-derive ni Pababer sa isip, eh, no? Yan, nalaman niya kagad, 'di ba? Ito, this is something na medyo complicated na, eh, no? So, okay lang ba? Ayos lang ba? Hindi pa kayo galit? Hindi pa. Ito kasi yun eh, no? Bukod sa mga lesson na ganyan, no, sometimes I teach my students ways on how to memorize a formula. So okay lang ba guys, mag-share ako ng way kung paano i-memorize tong formula na to? Ayos lang ba? Okay lang. So mag-share ako ng, yeah, okay lang, no? Oo, no? Yun, ayos, ayos. Nice, good, nice, good. Kahit ayaw nyo, i-share ko pa din. Wala kayong magagawa, guys, no? Okay, ganito, no? Alam niyo guys, yung parang ano, pag may narinig kang kanta, tas parang paulit-ulit mo siyang nakakanta subconsciously. Ano tawag doon? Yung parang may narinig kang very catchy na tune, tapos subconsciously nakakanta mo siya. Ayan, LSS, di ba? The Last Song Syndrome. Do you have any idea bakit may ganun? So, kasi guys, it's part of the ano no, human nature na mas mabilis tayong makapag-memorize no kapag may tune, kapag may tono, may music, no? So, I'm betting guys no na mas marami kayong memorize na mga kanta, mga lyrics ng kanta kaysa sa formula, o 'di ba? So, yan, bilangin mo yung memorize mong formula, bilangin mo yung memorize mong lyrics ng kanta, ay naku, ang dami mong memorize na kanta kumpara sa formula. So why not? Okay? Okay, ops, di nakailag, no? Why not we fuse it, no? So okay lang ba guys, no, na mag-share ako ng kanta para sa formula natin? Nice, good. Kinakabahan ako guys. Nakabahan ako. Okay, no? So, okay lang ba mag-share ako ng kanta para sa formula natin? Ayos lang? Yes. Kakanta ka, sir? Oo, kakanta ako, no? Alright. Oo, no? Okay, game. Guys, hindi ako magaling kumanta, ha? Wag niyo ako i-bash. Tapos medyo luma na yung kanta, guys, eh. So, pag hindi niyo alam yung kanta, wag niyo ako i-bash, no? Kasi ibabagsak ko kayo kagad, no? Pag binash niyo ako. Alright, no? Game. Let's do this. Minsan, hindi ko alam kung ba't ko ginagawa yung mga ganito, eh, no? So, game? Ready na? Alright. So, bigyan ko kayo ng, kasi medyo luma na yung kanta guys eh, baka hindi nyo na alam. Pero alam nyo guys yung ano, yung mga minions. Alam niyo yung mga minions? Ano yung palabas ng mga minions? Yung mga saging. Yung mukhang saging na mali. Ano yung palabas nun? Ano yung movie nun? Oh, Despicable Me. Pero yung 2 yung 2 guys, yung 2. Despicable Me 2. Yan, no? Sa ending nun guys, sa ending, kinasal yung bossing nila, di ba? Sa Despicable Me 2. Sa ending nun, kinasal yung bossing nila. Tapos ito yung kanta nung kasal ng bossing nila. Ready na? Game? Let's do this. I swear. Eh, naka-square. So, dalawang beses. Game I swear. I swear for SWRP incident. Oh, nakakaya ko. Grabe. Payang-paya ako dun. Di ba? Bad trip. Woo! I swear. I swear for SWRP incident. Woo! Yung parang pagkakasabi ng Demisilio, ang galing po sir, parang ano yun, nakakaloko eh, no? Parang sarcastic eh, no? O, di ba? Nice, good, no? Mm. Eh, di ba, pagka ano, no? O, di ba kapag kakanta ka, syempre pag kumakanta ka, alam ka namang mataas ka, agad, hindi naman, di ba? So, kapag kumakanta ka, mag-i-start ka sa mababang tono, no? So, that's why nasa baba yung I swear, kasi siya yung umpisa, di ba? Nasa denominator. I swear, I swear, for SWRP incident. Woo! Grabe guys, nanginginig ako sa kahihiyan, no? Hirap kumita ng pera. Okay, no? Bad trip ang putik. Anyway, that's it, no? So that's it, no? Ayan, no? So, woo! Back you, sir. Ang taba mo. Alright, no? So, ganun guys, no? Kunyari may mga formula kayo na mahirap i-memorize, di ba? So, pwede nyong, gawan ng kanta, o di ba? So, isipin nyo guys, no? Pag nagawa nyo ng kanta lahat ng formula natin sa Transma, pwede nyo na ilagay sa Spotify, o di ba? Spotify playlist, the Transma Collection. Woo! Sabi, nakakahiya ako. Ayoko na. Okay, so anyway, that's it. Woo! Nanginginig ako sa kahiyan. I swear for SWRP incident. Woo! Ayan, no? Okay, anyway. Kakahiya ang putik. Alright. So now guys, no, this would be our last topic, no, for today's session. Okay, so the impedance of a section of the transmission line. So although konti na lang naiiwan, medyo mahaba pa kasi ito eh, no, yung transmission line instruments. Okay, as well as the systems analysis. Okay, so may seatwork kayo guys, but hindi pa to kailangan gawin. So next week nyo na siya gawin guys, no? Oo. So bali after this lesson, no, I mean after this topic, pwede na pong magpahinga, right? So game, let's study this one. The impedance of a section of a transmission line. So the idea here guys is ano no, kunyari meron kang transmission line and you actually cut, okay, or you obtain a certain section no of that transmission line. Yung certain section na yun guys ay may corresponding na impedance. Okay, take note guys na hindi po siya characteristic impedance, no? Hindi yun yung characteristic impedance. Yung mismong specific length ng transmission line mo, meron siyang impedance. Okay? And that impedance is given by this formula. Okay? So ZO times ZL plus JZO tangent beta L divided by ZO plus JZL tangent ng beta L. Okay? Yan. Ngayon, galing dito, we can actually derive na kapag shorted ng transmission line mo, ito na lang yung formula natin. At kapag open naman ng transmission line, ito naman yung formula natin. So we will not show that anymore guys, no, because you can do it on your own. But the idea here is kapag shorted, ZL mo is 0 and kapag open, ZL mo is infinity. So kagaya ng ginawa natin sa special cases, so ganun din para ma-derive tong dalawa. Okay? So, bakit mahalaga no, yung pagkuha ng impedance ng certain length ng isang shorted o isang open transmission line. Ito kasi yun, no? Tingnan nyo tong figure natin, guys. Okay. So, ito, yung lambda over 4 medyo gumalaw, guys, eh. Dapat nandito yan, eh. Kita nyo yung laser na red. So, dapat nandito po siya. So, if the length of the transmission line, tapos shorted siya, ay saktong lambda over 4, it will behave as a parallel resonant circuit. Okay, guys? So, kapag saktong lambda over 4 yung length ng transmission line natin, tapos open naman siya, it will behave as a series resonant circuit. Okay? Again, itong dash line na to, guys, that's lambda over 4. So, itong susunod, guys, if the length of your transmission line is short, if the length of your transmission line is is less than lambda over 4, tapos shorted siya, it will behave as an inductor. Okay? As in inductor talaga mismo, guys. Tapos, kapag yung transmission line mo naman is, ano siya, less than nung lambda over 4, nung length nung transmission line less than lambda over 4 yung length ng transmission line, tapos open circuit siya, it will act as a capacitor. Okay, so I hope na nakakasunod sa figure, no? So again, if the length of your transmission line is greater than lambda over 4, kasi lagpas siya doon sa dash line, so tapos shorted siya, it will act as a capacitor. And finally, guys, no, if the length of your transmission line is greater than lambda over 4, tapos open siya, it will act as an inductor. Okay? Mahalaga ba yan, sir? Yes, no, that's important. Okay? Because it opens a lot of possibilities with regards sa transmission line. Na pag binago-bago mo pala yung length nila, okay? Pag binabago-bago mo yung length nila, mababago-bago yung type ng component na nandun. Okay? And you can actually make a resonance circuit out of it, di ba? So depende kung open or shorted. Pwedeng series resonance circuit, pwedeng parallel resonance circuit. Okay? Depende sa length. Babago-bagoy mo yung length, mababago-bago yung type ng transmission line mo. Mababago-bago yung equivalent component. So, babalikan natin yung concept na yan no, pagdating natin ng antenna. Okay? So, because basically, an antenna is just a transmission line. Ayun. And now, the last concept is yung impedance inversion. We will be discussing this again pagdating natin ng instruments. But because of this characteristic kung saan every quarter wave section, guys, okay, the impedance inverts. So, kunyari, maximum impedance dito, after lambda over 4, low impedance na siya. After lambda over 4, high impedance na siya. After lambda over 4, low impedance na siya. The same goes with voltage and current. So, kunyari, nandito voltage maximum. After lambda over 4, voltage minimum. After another lambda over 4, voltage maximum uli. And after another lambda over 4, voltage minimum naman. Okay? So, I know na masyadong overwhelming yung pinagsasabi ko, no? Sir, wala na po kami na-get, sir. So, I think we should answer no a problem for us to understand yung pinag-aaralan natin. All right? Okay. So, answer tayo ng guided problem solving, guys. I swear. I swear. Diba? Puro kalokohan eh, no? Okay, game. Let's do this, guys. Calculate the impedance looking into a 50 ohm line, 1 meter long, terminated with a load impedance of 100 ohms. If the line has a velocity factor of 0.8 and operates at a frequency of 30 megahertz. Okay, so for this one, let's say that this is our transmission line. This is terminated with a certain value of load impedance. So in this case, 50 ohms daw to. Joke, 100 ohms pala. Alright? Tapos yung ano daw yung impedance niya dito? Again, this is not the characteristic impedance. So yung impedance na tinutukoy dito is yung impedance ng certain length ng transmission line natin. So in this case, the length is 1 meter. Okay? We have a Z sub O of 50 ohms. Okay, so gagamitin lang natin yung ano, no? Gamitin lang natin tong formula natin. So what is our formula, guys? So yung Z natin ay equal sa ZO okay, multiplied by ZL plus JZO tangent of beta L, okay, divided by ZO plus JZL tangent of beta L. Okay? So, nakakuha ba? Right. Uh, Everything is already given except for beta. Okay? So, ano ba yung beta natin? So, that's 2 pi over lambda. Okay? So, 2 pi. Okay? 2 pi over lambda. Pero yung lambda natin ay BP over F, right? So, bali parang 2 pi F, okay, over BP. Pero dito, hindi VP yung gagamitin natin but rather CVF. Okay lang guys? Nakasunod ba sa mga formula na pinaglalagay ko? Kasi 'di ba yung beta is 2 pi F over VP. But our VP is CVF. Kaya naging ganyan. Okay? So we have what? We have 2 pi. Okay, multiply by the F which is 30 megahertz. 30 times 10 to the 6 divided by C which is the speed of light. So that's 3 times 10 to the 8. Multiplied by the corresponding velocity factor which is 0.8. Guys? So what is our beta, no, if that's the case? Okay, we have pi over 4. Okay, so we have pi over 4 radian per meter. Okay, so game. So hence, we can now solve for the corresponding value of the impedance. So we have 50 times the quantity of ZL, which is 100, plus J times 50. Okay. Tangent ng beta L, guys. So yung beta natin is pi over 4 multiplied by 1. So here, make sure that your calculators are set to radian mode. Okay? So dapat naka-radian mode yung calcu, ha? Tapos, kasi beta L, so beta natin is pi over 4 and yung L natin is 1. We have 50 plus J times 100. Okay, tapos tangent ng pi over 4 times 1. Alright? Okay. So what will be the value of Z? I swear. Anong makukuha natin, guys? Medyo mahaba nga lang, no? I-type sa calculator. Make sure that your calculators are set to radian mode. So, anong makukuha, guys, bale? By the way, pag impedance pala, sorry, no, hindi po dapat naka-polar form. So, dapat naka-rectangular form naman. Okay? So, dapat naka-rectangular form, guys, kapag ka ang impedance yung tinatanong. So, paki-ayos lang, guys. Ayan, we have 40 minus J 30 ohms. Very good. We have 40 minus J 30 ohms. So, yun yung convention, guys, yung polar form, that is only for reflection coefficient. Pero pagka impedance ang question, guys, make sure that naka-ano naman siya, naka-rectangular form. Para kitang-kita nyo, guys, kung may imaginary part o wala. Okay, so that's the idea behind that. Okay? So, ibig sabihin, no, yung 1 meter pala na transmission line, kapag terminated with 100 ohms na load impedance, will actually give an impedance equivalent to 40 minus J30. Okay? And that opens up, no, a lot of possible applications ng transmission line. Bukod doon saan? Bukod doon sa pag-transfer natin ng energy from one point to another, no? So it opens up a lot of possibilities. Right? Okay. So wait lang, guys, no. All right? Oops. Okay, so this is the last problem that we have for the day. So a 50 ohm short-circuited line, okay, operates at 500 megahertz. Determine the equivalent reactance of this component if this line, if it is A, 0.1 lambda and B, 0.375 lambda long. Okay. So, for this one, ano yung pinaka-governing formula natin? Remember, hinahanap natin basically the impedance, okay, of a short-circuited transmission line. So, anong gagamitin nating formula for that? Ito po yung no, Z equals ZO, JZO, tangent beta L. Okay, because we are talking about the impedance of a shorted transmission line. So ito yung gagamitin natin na formula. Hindi yung mahaba kanina, no? Kasi yung mahaba kanina formula, that is for the general formula. But this one specifically pag shorted transmission line. So, bali dito natin ano to guys, no? Dito natin magagamit yung diagram na dinidiscuss ko kanina na baka hindi niyo naintindihan, no, kasi ang bilis ko magsalita. Okay? So, this one guys. Okay? So, mapuprove natin tong nandyan sa diagram mamaya. Solve lang tayo. Okay, so for part A, let's do this guys. So for part A, the length of the transmission line daw is equal sa 0.01 lambda. Kakaiba, no? Anong tawag natin uli dyan sa ganyan? Kapag yung length ng transmission line mo ay naka-express as a fraction of a wavelength. 0.1 lambda, 0.375 lambda. Anong klaseng length yan? Kasi kanina yung 1 meter actual length, di ba? Or the physical length. Now, ano tawag natin dyan? Kapag yung length natin is naka-express in terms ng wavelength. Yeah, we call that as the electrical length. Okay? So, length pa din yan guys, no? Pero electrical length nga lang. Right? So, gamitin natin yung formula. So, we have Z equals JZO. So, what is our Z sub O guys? 50 ohms. Okay, tapos tangent ng beta L. So, ang kagandahan kapag ang involved is electrical length, we don't need to solve for the velocity factor, everything. Yung parang ginawa natin kanina. Just merely substitute 2 pi over lambda, okay na yun. Gets? Multiplied by the length. Ano yung length natin? Sabi rito, 0.1 lambda. Kasi if that happens, lambda would just cancel out, right? Okay, so what will be the value of the impedance of that shorted transmission line, 0.1 lambda in length? Kasi di ba JZ o tangent beta L? So what will be the value of Z in that case? Okay, we have J36, okay? So we have J 36.33 ohms. All right. So, ngayon, impedance kasi siya guys di ba? So, impedance siya, meaning to say, meron niyang real part, di ba? So, yung Z natin is actually, pag sinulat mo siya in a full context, 0 plus J, okay, 36.33 ohms. Ganyan dapat yan. Pero dahil 0 yung ating real part, ibig sabihin, this one, anong description natin dito sa impedance na to? This is reactive. Di ba? Kasi J lang reactive siya. Specifically, anong klaseng reactive component? Anong reactance yan? Pag positive ang J mo. Yeah, inductive siya basically. We have inductive reactance. So therefore, yung XL mo, pag XL na guys, no need to include the J. This is simply 36.33 ohms. At ito yung hinahanap sa problem. Ano daw yung equivalent reactance? Okay, yeah, very good. Inductive reactance siya. Now, bukod sa inductive reactance, hinahanap sa atin is ano daw yung equivalent na component. So, ano bang formula ng XL? Natatandaan pa? Di ba 2 pi FL? So, 2 pi FL equals 36.33. So, we have L to be equal sa 36.33. Okay, divide by 2 pi F. So, we have 2 pi multiplied by 500 megahertz. Because that is the operating frequency. Okay, so what is L, guys? So anong lalabas? Okay, you have 11.56 nanohenry. Okay? Okay, so ngayon balik tayo do sa figure, guys. Okay? The length of the transmission line is zero point 0.1 lambda. Okay, zero point 0.1 lambda is how do you compare zero point 0.1 lambda kay lambda over 4? Take note that lambda over 4 is 0.25 lambda. So how can you compare yung zero point 0.1 lambda kay lambda over 4? Mas maliit siya, mas malaki. 'Di ba? Zero point 0.1 lambda. Ang lambda over 4 is 0.25. So mas maliit siya, 'di ba? So sa figure, guys, alin dito yung mas maliit kay lambda over 4? 'Di ba ito? Tapos shorted siya. So ano equivalent component? Inductor. Okay? So naunawaan niyo na? Nagets ba yung pinagsasabi natin, guys? All right. Okay? Naintindihan? Okay. So let's have letter B. So letter B is 0.375 lambda long naman. So we just repeat everything that we did, no? So for part B, daw, yung length natin ay equal sa 0.375 lambda. Okay? So gamitin natin yung formula. So Z equals J ZO, which is 50. Tapos tangent ng beta L. So yung beta natin is 2 pi over lambda again. Okay, multiplied by 0.375 lambda. Okay, so cancel na to. Sige, guys. What is Z? Okay, so we have negative J50 ohms. Okay, negative J50. Alright, so negative J50, anong klaseng impedance yan? 'Di ba? Kasi wala ka uling real part eh. 'Di ba? Negative J lang eh, no? So reactive siya, 'di ba? So specifically, what type of reactance is that pag negative J? What specifically na reactance 'yan pag negative J? 'Di ba? Negative J kasi eh. So ano specifically na reactance 'yan pag ganyan? Capacity, very good. So therefore X sub C 'yan. So yung X sub C mo, okay, take note marami nagkakamali dito. Pag kinuha mo yung X sub C, you don't need to put negative J. You just put 50. Okay, 50 ohms. So that is your capacitive reactance. Okay? Now, for the equivalent component, no? So ano bang formula ng XC? So that's 1 over 2 pi FC, right? 1 over 2 pi FC is equal to 50 ohms. So therefore, if you want to solve for C, it is simply equal sa 1 over 2 pi times 500 megahertz times 50. Okay? So what will be the value of C? Okay, we have 6.37 picofarad. Okay, the numerical value doesn't matter really, no? So what matters is, okay, yung ano niya, yung analysis natin sa kanya. So look at this, no? Look at this, guys. Our length is 0.375 lambda. Obviously, 0.375 lambda is higher, di ba? Than lambda over 4. Right? That is higher than lambda over 4. So pag higher than lambda over 4, longer than lambda over 4, tapos shorted, it will act as a what? As a capacitor. Okay? So, naiintindihan, guys, yung figure, yung illustration natin? Nagagets na? So, ibig sabihin kahit pala sir hindi namin alam yung illustration, we can actually solve this one. Yes, no? If you know the JZO tangent beta L. Pero syempre kung alam mo yung figure, mas madali mong ma-answeran yung mga questions. Diba? Okay guys? So, nakuha po ba? Nakuha naman? Naintindihan po? Nagagets ba? Yes? Yes? Yes, sir. Okay. No? All right. So, and so actually that's it guys, no? For today's session. All right? Kasi yung next topic natin dito is transmission line instrument. No? So medyo madami pa to. So let's continue this next meeting, no? Because I don't want to consume no all the time. Okay, para din medyo mapahinga ang brain cells nyo, no? Dami natin pinag-aralan today. I swear. I swear. So yung seatwork guys, kindly reserve this for the next meeting. So next meeting na natin siya pag-aaralan. This one is very long, no? Yung transmission line system analysis. So please be prepared for that as well. Okay? So with that, no? So thank you everyone, no? Salamat for attending this session. Nice, good. All right, no. Okay? So